So hello everyone, I'm Saima, I'm VP AI and Computer Vision at Tribun Health, and today I'm going to talk about some of our AI solutions for improving cancer diagnosis and patient care. So bring to light more than the eye can see is really our mission at Tribun Health. So we are providing our client with a platform for managing histopathology slides and for analyzing also the slides. So we really want to understand what is understand cell and tissue to improve cancer diagnosis and patient care, and this is how look like the images that we are processing. So we provide our client with a unique platform that is completely integrated to their workflow. We are based in 2 continents in Europe and US. We have more than 15-year experience in pathology with a strong footprint in Greater Paris hospitals. We are more than 40 people who work every day on pathology problems and software and business, and we have more than 200 customers worldwide. So we have many strong partnership with academic and medical centers like Gustave Roussy, Greater Hospitals of Paris, SciPath, and many others who provide us data also for building our AI projects. And the quality of our product and services are organized through being best in class and through many challenges and publications. So this is our AI team. We are 8 persons in AI teams, data scientists and computer vision engineers. We daily work with pathologists who give us an understanding about what are the slides that we are processing, who also help us with annotation, because as you know, we need to annotate the slides for training our models. And we have also a scientific advisory board who mentor our development to make it centralized around the pathologist need. So what makes our AI different than any other AI? So we really designed our AI to respond to different challenges in histopathology. So first of all, we know that there are many scanners and staining process in the market. So we are developing an AI that is robust to this variability of scanners and stains. Second, we know that some pathologies are really rare, and we cannot collect them in a massive way. So we are implementing a kind of AI that is called data efficient learning, which consists in using a few data, but in a very efficient way. Third, we know that the data that we are processing is very sensitive, so we are using patient data. So this data need to be protected, and that's why we are implementing federated learning, which consists in keeping the data in the medical centers. So we only transfer the model weights, we don't transfer the data. So now I'm going to show you some examples of our AI for improving the diagnosis of cancer. So as I said, so our AI is really available in web platform that is fully integrated in the pathologist workflow, which could be run either on-premise or on cloud, according to the preference of the center. And now I'm going to show you some real examples of our AI tools. So this is my first example on colon polyp lesion pre-screening. So with our AI, we can obtain this kind of class map, which allows to identify the different lesion on the slide. And that can guide the pathologist's attention toward the risky area, because the slide that we are processing are really very large, 1 gigabyte per slide, and it is difficult to look at every small part of the image. So by having this tool, we reduce the risk of missing an important lesion, and we increase the confidence of the pathologist when making the diagnosis. Here, my second example of breast cancer biomarker scoring. So when a cancer, non-invasive cancer is confirmed, the pathologist usually ask for scoring a suite of biomarkers that allows to identify the molecular profile of the patient and allows also to identify which therapy is convenient to that patient. So the pathologists need to count or at least give an estimation of positive cells on the slide, and then they establish a score. And that's what we exactly do with our AI. So we are counting cells and we are computing a score in a very fast and efficient way. So we spend 4 minutes for the whole bunch of 5 biomarkers, which allows the pathologist to gain around 30 to 50% of the diagnosis time. So all of the AI is designed to be interpretable, because we don't only provide a score to pathologist, we also tell him how we come up with this score. So we provide a mask that tells the pathologist what the model is looking at, what are the cells that are counted in the score, and that's really very important to have the trust of the pathologist. So AI generalizability is really one of our major concerns. We don't want to make an AI that works only on one scanner on one center. We really want it to be generalizable to different scanners. And on this image, you can see how different are the images from one scanner to another. Last year we participated to one data challenge that actually addresses the problem, and many AI competitors submitted their code and their models. And then all the models are tested on the same platform, the same test set, and they are compared all together and sorted according to their performance. And we were the first ranked vendor on this data challenge, and the third among the whole participants. So that shows the generalizability of our AI models. And now I'm going to speak about AI for pharma, and how actually this AI can enable us to discover new treatment pathways. So I'm going to specifically talk about one of our projects that we led last year with Sanofi about how with AI we can better stratify patients for immunotherapy decisions. So immunotherapy is really known to be very efficient for treating specifically patients with NSCLC, so a particular type of lung cancer. But actually the guidelines for selecting patients who are eligible to this therapy are really very limited. So mostly they are based on some biomarker that is called PD-L1, which lacks of specificity, because more than 50% of patients that are who are PD-L1 positive are not responding to immunotherapy. And also this biomarker is really very, very challenging for pathologists to score. So there is a weak reproducibility in the scoring between pathologists. So really challenging biomarker. So I'm gonna how AI actually can help in this case. So we developed an AI that can predict from a basic histopathology slide the patient survival. And we leave the AI decide about the relevant patterns that are correlated to the survival probability. And we actually, with this kind of AI, we can discover new characteristics of those patients that have more chances to survive. And we actually have interpretable models that allows us to better understand the AI decision. So we have a class map that indicates to us what are the different patterns found by the model. And we have attention weights that tells us what are the most important patterns that are implicated in the survival decision. And when we actually analyze this, the most important patterns, so here my most important patterns are corresponds to the first and second columns. The two last ones are not that important. So what we found after analyzing that is that actually the model is based on PD-L biomarker, but not only that, it is also based on how the immune cell infiltrated the tumor. And that's actually one of interesting findings that could be important for the pharma to know how to better target the therapy and maybe also through clinical trials. So just to end this talk, I just wanted to say that what I showed you today is really very few examples of what AI can do in histopathology. The domain is really very, very vast, and there are a wide range of therapeutic areas and applications that one could imagine. So at Tribun Health, we develop our own AI, but we also include in our platform third-party applications, because our ambition is to cover as much as possible the pathologist need. So just to finish, this is a list of AI application that is available in our catalog. So we have in-house application that covers breast, colon, cervix, lung, and liver. And we have two-third applications that are coming from two companies, DeepIO and MindPeak, on prostate and breast. And we will have more application that will be coming very soon. So I'd like to thank you for your attention, and I think I have time for questions.